All right, good evening everyone. I'm Kris Rivera. I work at DivvyCloud. We are literally right down the road. I think it's that way. I can't remember the directions when we get up here. I am DivvyCloud's front-end software lead, and we make software for managing your cloud resources and ensuring that they're compliant and that they're secure as well. So this is my intro to TypeScript talk. So first off, let's start at the beginning. What is ECMAScript? It's commonly known as JavaScript, but it is the standard upon which all of the different versions of JavaScript prior to ECMAScript were put under that umbrella of ECMAScript. So they standardized it first in 1997, so quite a long while ago with ES1. And I just want to, on this slide, point out that, yes, they did standardize it, but there was either very long gaps of time or really short periods of time between different versions, and I believe they even skipped 4. It was 1, 2, 3, and then 5. So it was a little erratic back then, but starting with ES5, they started to become a little more standard, a little more organized on this. And so here, everyone who's in here or who has done any JavaScript development, this is basically ES5 language using vars and a little bit of node require in here. So nothing, nothing terribly exciting. But so ES5 is what most JavaScript developers actually write in. It's not even ES6, it's ES5. And some of the big features why, or the reasons why ES5 was so popular is that they introduced a lot of things that made JavaScript a much more viable programming language to use. And is that mine? Do I need to be muted? Someone slacking me? Yeah. Someone slacking me up in here? I might have to switch over and kill that. Let's see. And so strict mode and immutability, object array, such as a lot of different big features that we use in JavaScript were introduced in ECMAScript 5. And the good thing about it current day is that it's fully supported by every modern browser available, and even more so, even server runtime environments as well as mobile browsers. So it's pretty well supported. And we moved to ES6, which was released in 2015, so don't get confused by the years and the versions here. But this is the first edition of ECMAScript that was actually provided to the general public with a guarantee. Okay, I'm gonna. Sorry, I apologize for that. Give me 1 second. I can't actually mute my speakers here because I'm projecting. So, and let's go back. Great. I'm glad that's recorded and on the slides here. Let us continue. So, some of the big features of ES6 are really tightening down and making JavaScript a even more viable programming language where we're able to define lets and consts and get away from that global construct of var that leads into scope bleeding. Modules and classes are something that are far more well known amongst other programming languages, and something that was really big was promises. Promises helped us to handle asynchronicity across our different API calls. So just a lot of fantastic, a lot of different fantastic features that came in ES6, and still mostly very well supported. Everything basically except for IE11 and Node 4 server. Now Node 4 is pretty old, so we're not too worried about not having ES6 support there in IE11. And also similarly across the different mobile browsers, we have pretty well supported here. So that's pretty good. A lot of really good features here. And as we stated, part of the annual upgrade promise to give you a new version of ECMAScript as we move along. So we jump into ES7, ES8 released respectively in 2016 and 2017. And again, these are just marching along the annual releases. So here, you can see that there's not really too many new features they're adding to the standard, but the exponentiation operator. One big one is definitely the async await, where it helps to make asynchronous processes look and behave more serially in your application, so you can handle it a little more organized instead of having to do a big .then chain. So that is pretty good, but smaller feature set. But now we start seeing that the supported browsers are kind of begin to dwindle. So only the bleeding edge versions of the browsers support the bleeding edge version of ECMAScript. So there's starting to become a problem around browser support here. So how do we use the new features? Honestly, you either have to do one of two things. You have to exclude browsers from your support list, which hurts your customers, or you force your customers to use new browsers again. And especially if you work with a company that supports a lot of either corporate or even worse, government, not worse, but like more strict. Not worse. You know, it's everyone's opinion, whatever they feel, right? But they can't move, so you just lose out on a huge customer pool if you're making and using the newest version of ECMAScript. So obviously, there's something wrong here, something not right here. So one way to handle this issue is using transpilers. And the word transpilation means to take one language and convert it to another. And it could be JavaScript to JavaScript, where you can basically downgrade and compile your ES6, ES7, ES8 version of your code and compile it down. But now you're having to add some tools to your tool chain and on top of your already potentially complex stack just to build your front-end application. So, I mean, this is a possibility, but it's not that good. So you see, we have this development of like the gaps between 97, 98. It's, you know, we're getting into the good cadence. We're getting into new features. We're getting more advanced, right? But with that comes a price. So is there a better way to do this? Well, of course, it's the topic of the talk tonight. Is TypeScript, of course. So TypeScript was first released in 2012 by none other than Microsoft. Now, I know that Microsoft has had a large stigma around writing good software, but I promise you this is like one of the good ones here. Not all of them, but this is definitely one of the good ones. So it's open source language, and it has some pretty wide adoption by Angular, of course. I mean, that's topic. You know, everyone who does any Angular development knows that it's TypeScript that they use for their supported language. Even Vue and React also support it natively as well. React uses some library because it's all library bound, so you know. But what is TypeScript though? TypeScript is a superset of ECMAScript. So TypeScript simply is ECMAScript, but with a huge feature set on top of it. And not only is it ECMAScript, it's when you update to the latest version of TypeScript, you get the latest version of ECMAScript with it. It's because they have those standards. They will make sure to implement the bleeding edge with you and make sure that it's supported in TypeScript. So what does TypeScript do? It comes with the TSC, the TypeScript compiler, which will take your TypeScript code and compile it down into ES5 code or ES6, whatever target version that you feel that would work best for your customers. This process ensures that there's compatibility with all major browsers, and while still having access to all the latest and greatest features, plus anything new that TypeScript brings with it as well. So you say, well, I can get the same thing by using the latest version of ECMAScript and then transpiling it down. Well, yeah, you may get the language compatibility, but then you're missing out on the huge feature set that is typing of your entire code base. So here are some of the features that we will cover tonight. And so TypeScript brings so many features. So I had to keep the slide ultra short because if not, it would just go for a couple of slides here. But simple types and assertions. If you're coming from a language that does hard typing like Java or C++ or C# also has hard typing in it as well, you'll be very comfortable in this land. Interfaces, the same thing. Classes and inheritance, generics. It has so much. They're really separating themselves as not a scripting language. It's a legitimate programming language. So for tonight, we're going to go over basic types and assertions and interfaces. So let us move on to the first part, which is basic types and assertions. So across the top here are the basic types that we have available to us in TypeScript. Boolean number, string, array, tuple, null, and so on across here. So this slide, let's go over the different, how we not only assert what the type of a variable is, but what TypeScript really gives to us the power. So the first example is about Booleans. So in this example, you see the keyword let up here, and we call it is done, and we type it by the colon. The colon is saying is done is a Boolean, so that anything after the equal sign has to be a Boolean. If you try to, that's very different from how JavaScript does it, where you could say let is done and it could be anything. It could be whatever you want, and that's very loosely typed, and you have to figure out later. A lot of problems crop up during runtime. Here, if you try to do something incorrect, on accident, not on purpose, of course, it will, the compiler will tell you right away, hey, this isn't right. This is supposed to be a Boolean, not a string, not a number. So again, the type assertion is just colon, space, and the type that you want. Here's an example of how we use the number assertion, type assertion. So we say, okay, here's my decimal number, and they're all numbers. So it's just they're showing the different ways that you can easily use hex, binary, octal inside of. No one ever uses that. That's straight from their documentation to show you that you can. But like everyone uses only the decimal representation of the numbers. So again, the colon and the type tells us what this decimal or hex or binary or octal variables are supposed to be, and then anything on the right side of this has to be of that type. Same thing with string, but here the good thing about this is that with these, it's not just on assignment. It will on the next line if you try to type in a number afterward. Even though let is assignable, reassignable, it has to be a string. We told it has to be a string. So anywhere that it's used, anywhere that it's reassigned, anywhere that you pass it into, it has to be that string. So that's the beautiful part about TypeScript. It will error at you right as you're typing, not when you're trying to figure out why is this exception happening, why is this number not a Boolean or whatnot. So moving on, we have arrays. So arrays are defined in two different ways. They are either defined by the type with the square braces, or we can use the array class, and we use the generic brackets to put inside of there what that type of array is. So it's pretty straightforward. Then you have to define an array afterward. Here is something kind of interesting, and that we oftentimes at DivvyCloud use some form of the tuple, but here we're saying that, okay, well, my tuple has to be a string and then a number, so that when we attempt to initialize or even reassign, it has to be, index 0 has to be a string, and that index 1 has to be a number. And in this example here, you see that when we try to assign the number then the string, it fails right away. So that's our error here. And then finally, some very oft not used types are undefined and null, not for the sake of being able to check if something is undefined or null, but normally we don't constrain a variable to be of type undefined or null, but you can. And it's most useful when you're typing the return of a function instead of typing a variable as undefined or null. All right? We all good? Any questions so far while we're moving through this? Okay, cool. So here, we another few types here are any, enum, and void. So the type any is essentially stripping away the typing. It's saying this could be anything. Now you would say maybe why do you have to type it as any to get this same functionality? Because if it's typed as any, that means that you can reassign it as anything afterward. So if I were to drop the any off of this, the TypeScript compiler would infer that not sure is a number, and then these next lines would error on you. So you have to type it as an any to say we need to allow this to accept any assignment. Now, I'll tell you for sure, and my devs in the back could tell you, we never use any anywhere. Never. So everything is very strictly typed in our work.
If you want to create like a service, a class, and it just has an array of all the things they'll need, the name of someone, the number of their ID, and just the flags, and Booleans.
So that's
the permissions.
So that's a really good question, and I will show.
The type of any array.
Sure, that is a way that you can solve that, but instead we would most likely want to use a JSON object with hard typing inside of there too, and we'll get to that in a few slides later. But yes, we want to be able to know exactly what we're getting and what we're giving to different functions, different services and whatnot. The enum is something that, again, Java developers would be very familiar with, enumerations. An enum is simply a named value or named array. So red is represented as 0, green is 1, blue is 2. So it's just an array at indices, but you can actually use these as your own custom type definition. So you know, if you're talking about I want to make a ball red, you don't have to actually use the string red. You can use a very lightweight enumeration to say color dot red. It's a lot easier to read and you don't have to be passing heavy strings around, whereas a simple enumeration is just an integer. It's just one byte. So in the next example though, like what if, for example, you care about the value of the enumeration, like 0, 1, and 2 aren't telling me anything about what red, green, and blue are. So you can equally say, okay, I'm going to say red is 1, green is 2, blue is 4. It doesn't matter. You can assign arbitrary numbers to this enumeration, but you still reference them via the variable color dot green, dot red, dot blue. And it's very useful to use that. Recent example at work was that we have a new plugin that we're creating where everything is very tabular. You have to select different tabs, and we use an enumeration to tell what types of tabs they are. So we have an enumeration where it's tab resource, tab dot user, tab dot application. So we don't have to define or use strings and pass them around. String comparison is pretty heavy and brittle, but enumeration value comparison is very lightweight and very quick. So it's very simple, very easy to use, and we have something that we can tie a name to a numerical value. Does that make sense to everyone? Awesome. Now, void. So now we're getting into typing the return of a function, okay? So we're saying, in this case, we're defining the function warn user, and that colon void says this function does not return anything. It's not that it returns null, it's not that it returns undefined, it's that there is no return line in here. But it does get to the bottom of execution. So all this thing does is alert, and we make sure that it doesn't return anything by typing it as void. Now, moving on to the final two types and assertions, we have here another function called error. Now the never is a very, very super seldomly used type. And it's used in a lot more advanced cases, but in this case, we're showing you a slightly contrived example where the function should never reach the bottom of its execution because we're always throwing an error in here. If we were to comment out that throw new error, the function itself would get red underlines and say, hey, this function actually executes and gets to the end. So the never assertion can be used for a lot of different things, but in this case, this is one of them. And then we have the object type. The object type is basically saying it is a JSON object. It's some form of an object. So in here, we're showing something slightly more advanced as well. We're showing how TypeScript does unions as well, meaning that in this function parameter, instead of like in the top example where we know that the message has to be of some type string and it will error at you if the string, if you try to pass in something that's not a string. Here we can pass in something that's either an object or a null value. So that's why the create prop 0 passes, because it's a JSON object. Create null works because it's also satisfying that union operator. Again, the object pipe null means object or null. So it's but then the rest of the executions fail because 42 string false and undefined are not of the either an object or null. So it's very useful. It's very easy to make sure that you are typing in exactly what you need to. And even better is that the type ahead, when you go to try to execute create, it gives you some code syntax highlighting, and it gives you some hints at what you need to pass in because we know what the definition of this function is. All right. Any questions before we move on to interfaces?
What's it declare keyword?
The declare part here? Declare is, I wouldn't worry about that, but declare makes that global. It makes it globally accessible, which is something that is only, again, another seldom use. Normally, we want to keep things inside of the scope of a module or the function scope or something smaller. Okay? Yep.
Are there non-basic types and assertions, like more advanced ones other than these? Okay.
Yes, next.
Yeah.
So these are just the basic types and how we do assertions. But we get now into interfaces. So interfaces are, to break them down, simply a contract by which either an object has to behave or a function has to return. So here, we're going to show you some properties of interfaces. So this first example, we're going to define an interface in line. So let's break this down a little bit. So there's a lot of different things happening here. But up here, we have a function named printLabel. The parameter is named labeled object. And now that colon again is a type assertion. And what we are telling this is that now we're providing an interface. That right there is an inline interface saying that this labeled object has to have a required property label that is of type string. So we're asserting what the object has to be, and then we are making assertions about what's inside of that interface. And then what happens is that the console.log statement will log the label in this function. So in here, we have an object that has size and label. Now, what TypeScript does is something called duck typing, where basically, I believe if it looks like a duck, quacks like a duck, then it must be a duck. So though this object is not exactly that interface of label and string, it still has that property. Therefore, it satisfies that interface. Just because we have more stuff on it doesn't mean that it won't behave. It has the minimum required properties on there. So then when we call print label of my object, everything passes. And it prints the label. It prints size 10 object. But what if we need to define something more complex than just an object with label and string? Well, we can pull that inline assertion out using the keyword interface. We name it something, in this case labeled value, and it has it's the same thing. If we go back, you can see that it's still label :string inside of the curly braces, but if we move forward, now we're just pulling it away into its own interface declaration, and then we use it where we call print label of labeled object, and we just say now this has to be of type labeled value. It's the same thing as before, only it's a little more organized. It's easier to define these more complex objects external from where they're being used, and then the same lines of code satisfy as well. So what if we are now wanting to define an interface where properties are optional instead of required? It's pretty simple, fortunately. The question mark. The question mark here on the interface square config is saying, well, I have a property color that is a string and a property width that is a number, and the question mark means like, but it doesn't have to have it. Now, this is a pretty contrived example. Usually you would have an interface with a lot of different properties that are all required, and then like one or two, they're like, maybe it has this, maybe it doesn't. Maybe the server doesn't return the label in one case, but it does in another. So we need to be a little more careful about it. So when we say, now this, again, the function is a little more complex in here, but function create square has a parameter called config, and it is of type square config. Now this is an object that may or may not have color and width, but it's going to return an object that has color and area for sure. So in the first line, we're creating a new square. We just define it as color, white, area, 100. But then we say, if config.color exists, then new square.color equals the config.color. And if we have config, I'm sorry, I said config.color. And now, or so width. Now in the next line, if we have config.width, the same thing. The new area equals the width times the width again. So we have to check when we're using optional parameters, we have to ensure that those parameters on that exist on that object. Otherwise, you can get into a little trouble here. And then we just create the square, and it returns a new square that has the color with the new color, which is in this case black. But notice how we're only passing in color in this example. We're not passing in the area. So the area that we're going to get is 100 instead of some other area. So again, these are pretty contrived examples, but is trying to demonstrate what you can do with required and optional. So now let's go to read only. Any questions on required and optional parameters before we move on? I'm sure questions will get lost if we wait till the end. Good to go? All right, we are all TypeScript masters. Very nice. So, read only. So again, on an interface point, we have the read only keyword before. So it's not required, or it is required also because we don't have the question mark. So it's required and it's read only, meaning that once we create this assignment, we can't override it again. So in this example, we define a point dynamically, but it is a P1 point that is that is typed by a point by the colon and set equal to x10, y20. And if we try to assign x again afterward, you're going to get an error because it's a read-only property. So we don't allow you to assign things once it gets created for the very first time. Now, in addition to other function interfaces, we can define a function definition as an interface. So here, this search function is an interface for what a function has to abide by. So the inner part of the function has to be a source string and a substring, and it will return a Boolean value. So the way we use this is pretty simple. If we have a variable mySearch and we type it as search function, then when you assign mySearch to a dynamic function that we're creating, it has to abide by what is in the interface. So it's string, and it has to return at the bottom line if result is greater than or -1, or whatever other Boolean value that we can get here. So if any part of that fails, or any part of that deviates from the contract by which we've created this search function, then it'll error at you right in the console. And this leaves you a level of simplicity during development that you'll be like, oh, that's my bad. Not save it, run it. Ugh, why did that not work? And especially if you save it and run it, take some compilation steps also, you're wasting time in your development. Every single save, that builds up. That doesn't have to happen. Now here, something that's indexable is another type of interface. Here, we're saying, okay, and this is a little more complex to wrap your head around just because of the annotations used to make this, but what we're saying here is that I have an interface called string array. So what it's saying is that every key that's in this object has to be a number, and every value in this has to be a string. And so my array here is of type string array, and it so happens that an array object satisfies that. What's the key to every index is a number. It's 0, 1, 2, 3. And the values in this case are string Bob, string Fred. So most of the time how we use these indexable markers is to say more like a string, to say like, okay, we have a bunch of different key values that are strings and they have to be some other complex object. You don't always have to go right to a primitive type of string or Boolean or whatnot. So, but in this case, in this example, we're using the index is the number, so an array object satisfies this interface, this necessity to or type that we bind to the variable. I know that was a lot. We're still good? You got a question? Yeah.
So do you have an example of an indexable that's not one of the built-in types, like an array? Like, could I implement that interface with a function?
Oh yeah. Oh yeah. You could do anything that's after. So like, are you talking about here that instead of an index number, you can do like an index?
I'm talking so in that example there, the my array satisfies it because the array has the index of a number and the string to represent it.
Right.
If I wanted to create a function that implemented that interface without using an array, is that possible?
So it wouldn't be a function that would implement that interface. It would be an object that would implement that interface. And then you would have a JSON object that would have to satisfy this example. So the only thing that you can have in the index colon some type is a number, a string, and something else that it's not coming to my mind. It's like a symbol. It's a number, string, and symbol can be what is on the left side of the colon. Whereas on the right side, it could be anything that you want. It could be a function. It could be another interface object. It could be other primitive types. It doesn't matter. So what's on the right side lets you build these complex objects out. A lot of times what we do at work is that when we make a request to the backend, we get an array of these complex objects. And as to be able to look them up quickly by their ID, we take this array of objects, find every ID in there, and we store them in an object there where the key is their ID and the value is their actual, that complex object. And the interface for that is simply index colon string colon that complex object, and that's it. Well, it ensures that where we're storing it, it has to match, it has to be of that type. Cool? Any other questions before going? All right. So now we go to another example of something that is indexable. So we can also mix read only into this property, and it's very similar to what we did with the read only of just when we were breaking out the individual properties, those things we were telling it, okay, this is read only, this is not read only, this is read only. This is saying for every single entry into this object, it is read only. So when we define this read only string array, Alice and Bob, when we try to assign a new value or overwrite it, you'll get an error. It'll just tell you right there. You don't have to even save it. It's just right when you type it. Yep.
What if you did like my array 3? Could you add something new to the array, or would that not work either?
I'm wondering why even this example, the error would also be out of index, wouldn't it? Like you would have to push to expand the length of the array.
Okay.
I think the TypeScript documentation failed a little on multiple occasions here in this line. No, if you put the only way that you would be able to assign an index that's not previously defined is by creating a new array of a certain length, and then you can assign values within it. Mm-hmm. If not, if you were to expand the length of the array, you would have to push and it would expand the length. Okay. That make sense?
Yeah.
Yeah, so this line error is not only because it's read only, but also because actually, you know what? This would still work appropriately because this still satisfies the interface. This is actually kind of interesting here. Because the interface is technically a JSON object backing it, just because we initialized it with an array, this is still an object on the back. So we could say my array index 30, and it would still be okay because it's satisfying the number here. So if we go back, not the read-only part, but if we come back to this example here, because this index takes any number as its key and any string as its value, we could do myArray index 40,805 as long as it's a number equals something, and that would work. We're just instantiating this object with an array that says 0, Bob, 1, Fred. So that's kind of the flexibility. If we were using a strict array in this case, that was just an array object and not something that was like our string array interface, then we would get into that situation where we would have to push to extend the array. And in this case, my array, the string array, doesn't have the array properties on it. It doesn't have splice. It doesn't have anything because it is a string array object that we defined via this interface. Is not an actual array, even though we've instantiated it with an array object. So it lets you do some kind of confusing things. I would never suggest doing this. I would tell you to just make a JSON object and put in the actual keys and values that you want. But I guess the TypeScript docs want to go a little to the edge, huh? So this next one errors simply because those keys are all read-only once you identify them. I hope that answered your question.
Yeah.
Probably a little more than you wanted.
It's fine.
Okay. So now we get to class types. With class types, we can start defining far more advanced objects. So here we have an interface called clock interface where it has a current time that is a data object itself, which a data object is a complex object as well. And then a function called setTime that takes in a parameter d that is also a date. So you don't have to, you can mix and match, you can add whatever complex objects, or primitive types that you want. But this class clock implements clock interface. So that's telling this class that you have to have these things or you will be not correct. You'll be incorrect. So then you define the current time as a date, and you define the actual function setTime d and it as date, and it sets the current time to what you pass it. And then the other notion of a class, which is also, like I said, introduced in ES6, is that there's a constructor. So whenever you call a new clock, you have to pass in an hour and a number to it. And oftentimes you will do something inside of that constructor so that when you call new clock, it would usually set something up. It would probably create a date and then call setTime for you. But this is just ES6 code. I'm just showing the typing and making the class implement this clock interface so that it has to abide by this, meaning that when we make a new clock, we could say dot and it will say, oh, do you want current time? Dot, do you want a set time? And it just auto fills it for you. Now, what if we have a base interface and we want to be able to extend that interface? It's pretty simple. We have an interface shape that has a required parameter called color, that's a string, and we have an interface square that extends shape that has a side length property that's a number. So that means that anything that is a square has both the properties color and side length. So here we're doing something where this is another way of saying colon square. That's this example is maybe a little slightly confusing, but that's the same way as saying let square colon capital S square the interface. You can type objects before they're defined right in line. It's not a often used practice, but that's something that you can do. But all this is saying is that square, the variable is of type square. This type square extends shape, meaning that I have a side length and I have a color. Therefore, you're going to assign square and color and side length right afterward. Cool? So, where do you get all these awesome features? Where is this compiler? Where do you see this? Well, I'm sure plenty of you have heard of it, but it's Microsoft Visual Studio Code. That's where all of my front-end devs and myself use, and even some of the QA members are starting to warm up to it. Oscar, I'm looking at you. But it is honestly in my opinion, the best editor for JavaScript and TypeScript. It actually is built on, it uses TypeScript, it's built on Electron, and as newer versions of TypeScript come out, they update also Microsoft Visual Studio Code with it. So Microsoft is making both the language and the code editor, so they're married very well together. They tell you so much about your code. It lets you rename variables across multiple files as they're used, importing objects. All the typing is there for you. And it uses, like I said, the TypeScript compiler live to tell you if you have compile time errors. It's so useful. And you can download it at code.visualstudio.com. And that's it.